Now, what are breakpoints? Breakpoints allow you to tell the browser to stop code execution when a certain part in the code is reached. So for example, here we can go to the add function and place a breakpoint right here so that we stop code execution when we reach this line, so that we can then look into our code and its current state during execution. That's what we'll be able to do. Now, to place a breakpoint, you just need to click on the line number here and you see this mark. You can also place multiple breakpoints, by the way. Now, if you placed that, what will happen is that if you now run your code, in this case, when I add 10, you see now this gets frozen. You see this message here, paused in debugger. You can resume by clicking this play button, but let's not do that now. And here on the right, you see this line now gets highlighted in blue, which means this is where the code execution stopped. And now you can, for example, hover over things to see their current values. For example, since code execution always stops before this line where you placed the breakpoint is executed, you see that entered number is currently undefined. Makes sense, because as I mentioned, it stops before this is executed. So this is all undefined. Now you can step through your code with these controls down there. You can always resume, which means that it will continue running until it hits the next breakpoint if there is any. You can step over the next function call, which basically means you move to the next line. I'll show this later. You can also step into a function call. That would be nice here, because here we are calling a function, and by stepping into it, you see we now jump to that code which is executed in that function. And now here again, I can hover over this. Here, since user input refers to an element in my HTML page, I even get it highlighted on the left, which is another convenience feature. And here, since user input is a quite complex object, I can even find all the properties of this object and get the value that's in there, also by hovering over the value. And we see this is a string, 10. This might already allow us to fix this error at this point, but let's say we haven't fixed it yet. So we see that's a string. Okay, we're now done. We can now step out of the current function, back to the code where we had our breakpoint, and we're now in the next line, and we now see entered number is that string. Now we're not interested in this line, so we can just go to the next line with step over next function call or this button. The difference is that this will always step over the next line, and if a function is executed there, it will not go into that function, but just call that function and go to the next line with the result of that function call available. This, on the other hand, will always go to the next step, and if that's inside of a function, it will go into that function. So it kind of combines this button and this button. And we can go through our code with these buttons, therefore. You also see I got this nice output shown by the developer tools here, which shows me the values of entered number and initial result even without hovering over them. And that, for example, should already allow us to kind of fix the problem here, because now we see this is a string, and this might allow us to see that that might be the problem with our addition, that we're working with a string here. If I go over this line, we see current result is this concatenated string, and now it should definitely be clear that the problem is that we're kind of working with strings here. This would probably allow us to fix the error. Now, before we fix it though, let me show you what else we got here in the debugging view. At the bottom, for example, I haven't really talked about that besides these buttons. You see your call stack. The call stack is essentially a list of all the functions that have been called. Let's say here we go into create and write output. If I do that, you see now this is on the call stack as well. And below that is the add function. You can also click here to jump between the lines that are connected. What this means is that the topmost thing is always the function which is currently running, and below that you find other functions that were responsible for calling that function. So that kind of shows you the order of your code execution, if you will. There you also see the variables that are available, local variables and global variables. There, by the way, we have a lot of dummy variables because in the browser we got a bunch of general information about the window available globally. But that's also something I'll dive in later. Local variables here would be the variables available in this function here, and that are essentially all the different parameters I'm getting and calc description. And we can ignore this thing here for now. So that can also be really nice that you see which variables are available there and which values they currently have. You can even change the values here. For example, here we could change this to a number and change initial result to a number to see whether this now executes correctly. And if it does, we would see that the problem is not our addition logic, but the logic where we get the input. So changing these values here is also something useful you can do. You can also set up a watcher here. There you can add an expression where you want to watch certain values. You can either just enter the value name, like entered number, and now you always see the value of this variable here as it changes throughout your function execution. But you can also add a more complex expression like entered number plus current result. And now you will always see the result of this as your code executes. So this can also be really nice for keeping track of how things change during your code execution. Now, needless to say that all of that is lost and cleared when you reload the page or when you're done with the function execution. So this is really just temporarily there in memory to help you debug your code. So that were normal breakpoints and how we use the debugger here. Now there also are other breakpoints, which I want to show you before we ultimately fix this error here. For example, you got conditional breakpoints. Let's say you have some error which you noticed only occurs if you enter numbers greater than 100 here. So let me resume this here. I cleared the breakpoint by just clicking on it again. And now, of course, our error here doesn't occur just for numbers greater than 100, but let's assume that would be the case. In such cases, if you right-click here, you can also add a conditional breakpoint, which allows you to write the expression like only pause here if get user number input is greater than 99. So now we would only pause here if a number greater than 99 is entered. So therefore here, if I enter 100, you now see this pauses here. On the other hand, if I resume and I enter 5 here, this doesn't pause. So conditional breakpoints can be nice, and also very nice if we increase this at the bottom again, are the event listener breakpoints. Now we know something goes wrong when we click the plus button. It also will go wrong on any other button though, so we might not be interested in manually adding breakpoints here to add and subtract and to multiply. Instead, we might be interested in just pausing the code whenever a click happens. And you can do that with the event listener breakpoints. There, you can expand mouse, and there, click. If you click this, if you check this, now you will pause whenever a click occurs. For example, if I click here, now execution pauses in the first line of the function which is handling that click. And now we can navigate through that here. So now you see that pauses no matter where I click. Now important, it does not pause if I click anywhere else on the document, really only on event listeners I registered for click events. There it will pause. So let me clear this now because we don't need it anymore. We already found the error, but that's all important to be aware of.